Morning, everyone. Hope you had a good day yesterday. I'm sorry the video was quite so boring, very slow. Spend a couple of minutes on the warm-up, see what you can graph from that, and I'll go over it in a couple of minutes. Okay, so when we're graphing these, we graph the midline first, which comes from here. That's your midline. There's no vertical shift. And then your amplitude is from your vertical stretch. We're going to go up by 3, and that will give us our high points. And then we go down by 3, and that will give us our low points. Okay? So the pattern for a cosine, now these patterns, you have to memorize these. They're very easy, and I'll show you how to do that in a second as well. The pattern for a cosine goes high, middle, low, middle, high. And we're going to start on a high. These are y values. These are like y equals 3 for our high, y equals -3 for our low, okay? And y equals 0. I don't need these labels here. I need the information here. Those tick marks are sufficient. If you want to label them, that's good, but you don't have to label them as long as there are tick marks and I can see where those lines are supposed to be. So this one, there is a horizontal shift. Inside the cosine function, you're adding pi by 4 to all your x's. That's going to shift it left, and that's going to shift our start. We're going to start at x is -pi by 4. So let me put -pi by 4 here. And I'm going to be starting at a high. So this is my first point, -pi by 4 on high. And I'm going to take 4 steps. Now you can build a table. So just write out this pattern spaced out a little bit. High, middle, low, middle, high. These are your y values, and our first high is going to be at an x value -pi by 4. So putting this together, this sort of gives you a point. That's that point we just did there. At -pi by 4, I'm on the high line. Now to do the other ones, I have to take a step. I'm going to step through, and I'm going to take 1, 2, 3, 4 steps to get to the end of the wave. So we need to know this step size. To get the step size, another word for it is quads. I don't like calling it that. That seems to be something they just use at this school. But basically, to get your step size, your step is the period of the wave divided in 4. Okay? Sometimes you're going to want to actually work that out a different way. Remember, dividing by 4 is the same as multiplying by a 4th. So obviously we need to know the period. How you work out the period of a wave, it's simply 2 pi for the parent function, and we'll find out how we change that. But for the parent function, if there was a compression, if you were multiplying by a coefficient here, that would change the period. And we've got nothing here in this example that's going to. So our period is simply going to be 2 pi. So our step is simply going to be 2, oh, I've run out of room. It's going to be 2 pi divided by 4, which is pi by 2. So if I'm at this point here, to take a step, I have to add on pi by 2. -pi by 4 plus pi by 2. Now, some of you can do that in your head and some of you can't. I hope you would be able to work out that that's pi by 4. But what happens if you couldn't do that in your head? What do we need to make it easier to take the steps? This will be easier, and this is true on all of the graphs, if if the step and the start have the same denominator. Ooh, that's not spelled denominator. Whenever you're graphing them, look for the step and the start and give them the same denominator. That will make graphing them so much easier. So let's have a look at our step and our start. This one's got a denominator of 4, this one's got a denominator of 2. It would be easier if I turn this denominator into a 4 by multiplying by 2, which means I have to multiply the numerator by 2 as well. If I use a step size of 2 pi over 4, this would be much easier. Ooh, and that was negative pi by 4. Negative pi by 4 plus 2 pi by 4 takes me to pi by 4. When I want to graph the step after that, I'll add on another step size. And remember, I'm saying the step is 2 pi by 4. That would 1 pi by 4 plus 2 pi by 4 gives me 3 pi by 4. Add on another 2 pi by 4, and I'm at 5 pi by 4, and then I would be at 7 pi by 4. Okay? So let's have a look at this. I'm at negative pi by 4. Ooh, that's big. If I have to do 2 of those for each step, well, I can, before I start graphing, you know what I'm going to do? I'm going to cheat. I'm going to change the scale of my graph to make that smaller. I am so sorry. I know you can't do that as easily. Okay, just planning here a little bit. So my next point I have to graph is this one, which is at positive pi by 4. If that's negative pi by 4, positive pi by 4 will be about there. Then I'm going to have something at 3 pi by 4. It's 1 pi by 4. This point here would be 3 pi by 4. That would be 4 pi by 4. This will be 5 pi by 4. This will be 6 pi by 4. Here will be 7 pi by 4. Okay. Now let's look at just these. That first point was on the high line. At pi by 4, I want to be on the midline. At 3 pi by 4 here, I want to be down on the low line. Then I want to be back to the midline again. Then I want to be at the high line. That would be one complete way. Let me show you what not to do. Please do not join them up like that. Well, that wasn't too bad. They're never jagged. If I was going backwards, this would be negative 3 pi by 4, taking two little tick mark step, pi by 4, 2 pi by 4, this would be at negative 5 pi by 4, negative 7 pi by 4, etc., etc., etc. Think about what would come after this high. This would be at a low, at the middle, this would be at a low, this would be a middle, then it would be back up to a high. What the graph looks like is it's actually a smooth, continuous curve. Never has jagged bits. At the end, it doesn't go straight at one of these ones, it curves into it like that, okay? And we should always circle our starting point. So that's 2 complete graphs. At this point, do any of you have any questions? Are we doing okay? What am I doing? Okay, on day 2, right, talking about radio stations. I'm not going to be able to hear. What's your favorite radio station? Anyone, type in, what's your favorite radio station? Anyone in chat? Okay, somebody said the buzz. That's, how would I find it? Somebody said 93.7. Somebody said 104.1. Somebody said the buzz. Well, 104.1 tells you where to go. That is the frequency measured in megahertz of the station. and something else, let's do 99.1, Sunny 99.1. I don't suppose that's any of your favorite radio station. What these are frequencies. And they're in megahertz. They're very high actual frequencies. These are the frequencies of the FM signal for those radio stations. FM stands for frequency modulation. And the problem with frequency modulation is it gives you a really high quality signal, but it doesn't travel far. If you were listening to your car radio tuned into 104.1 and you're driving to Austin, about halfway there, you won't be able to hear the signal anymore. Okay, because frequency modulation has a very expensive transmitter tower they need for it to send it out, and it doesn't transfer very far. You'll also, on your radio, you'll have a whole load, I've never listened to any of these really. You can get something called amplitude modulation. And these signals, they're not as high fidelity. You can't send as higher quality musical note over them, but they go further. Now here, I think you can see what amplitude modulation does. Can you see the amplitude of the wave? Here it's small, and here the amplitude is really big. That's amplitude modulation. This is frequency modulation. Can you see that the one wavelength going from there to there, and here one wavelength is just that long. They're compressing and stretching the frequency of the wavelength of the wave, changing its frequency, and that's how they're sending the data signal over the airwaves. Okay, now you didn't really need to know that. That's more just sort of interest for you about why we actually do this math. Yesterday, everything we worked on all had the same period, the same wavelength. Today, we're going to look at how to change the frequency of a wave and to graph graphs with a different period than 2 pi. So let's have a look at some notes. First of all, write out this, write out quite big, write out this formula for a general function. F of x equals plus or minus a multiplied by your function. Now this word sine could be replaced by, you could write cosine here or tangent or whatever. Then parentheses, b times another set of nested parentheses here. Your variable, that could be x, it could be theta, it could be anything. We often use theta for angles, but we're using x here. Minus c plus d. And remember, if you don't factor out that b, your c, your horizontal shift, will be wrong. When we're graphing these sine and cosine waves, the very first thing we do is we actually graph the vertical shift. It comes from the end. That's going to give us the midline of our wave. The next thing we graph is the high and the low. The high and the low came from changing the vertical shift, which changes your amplitude of the wave. The high will be that value above the midline, the low will be that value below the midline. And ignore the minus at this point if there was one. The amplitude is always considered positive. What that negative would do would be to flip your pattern. It does a vertical reflection over the x-axis. Anything on your midline will stay in the same place, but highs will turn into lows and lows will turn into highs. You don't need to draw this next picture. It's just letting you know what a vertical stretch looks like. The amplitude, this would be here a wave with a smaller amplitude. That's your amplitude. It's just a distance. It's never negative. And the distance from the very highest point to the very lowest point is actually 2 times your amplitude. Then the next thing we graphed was knowing where to start your wave. And the start is affected by your horizontal shift. Okay, that's going to give you where your wave starts. And remember that it's what you're subtracting. If you've got minus c written up here, you'll be starting at x is plus c. Okay. So the thing that's actually going to change the wavelength, that's going to change the period, is this b. which gives you horizontal compression. That will change your wavelength. It actually changes the frequency of your wave. If you're talking about music, that's going to change the pitch. Amplitude changes how loud. Frequency changes the pitch of the note. This is the most important thing here. On this line here is worth creating a whole half a page all on its own in your notes. Write that and put a highlighter all around it. Period equals 2 pi divided by b. This value of b compresses the wave, so it gets the normal period and compresses it by dividing it by b, okay? This is what if this was your parent function, if b was 2, then you would get 2 waves. They would have been compressed so that 2 waves would have been in the space where 1 wave normally went, and you'll see that each wavelength, this period, would be half of the regular wave. Okay? It compresses your wave. I mentioned as I was writing it out, this bit is critical. Another bit is a very important note. You must factor out the B, or you'll see the start will be wrong. And if the start of your wave's in the wrong place, then everything else will be wrong as well. If there's the only thing in front of your X should be a parentheses. Or this C here will be wrong. The start will be wrong. It must be factored out. This is just showing you the D and the C put together on a wave. A wave starts at a horizontal displacement of what your C is, and a vertical displacement for your midline at whatever the value of D is, this D at the back here. So you don't need to write all this out. You can, if you want, you can come back to it. On this, I would just make this while you're writing important notes. Write that. The start and the step need the same denominator. Or if you don't do that, when you're trying to graph it and work out all the values on your x-axis, you're going to find it really, really difficult. Okay? You're giving yourself a headache if you don't do that. Sorry, I haven't got my camera going yet. I always thought AM was morning radio. That's funny. You can listen to AM overnight, actually. It comes through really strongly. Apparently, it bounces off the ionosphere at night. AM signals. Right, moving on. So, right, we could graph that one. I'm going to stick with, I know that we're going to run out of time if we do the easy ones. Let's just talk about how you'd graph this. The midline would have been shifted up 1. Your high and your low would be 2 above it, 2 below it. You'd be starting at -3 pi over 2, and you'd be doing a pattern of cosine goes high, middle, low, middle, high. Let's find something that's more interesting. That again is a bit boring. I'm looking for one where we've got a B, something more important to graph. This is the order you graph it though. Midline, high, low, where your start is, what your period is, what your step is. Then you look at the pattern. You can either do the pattern here or mention the pattern up here. It doesn't really matter. Okay, let's have a look at these. Okay, so start trying to graph those while I try and see if I can find my camera and get my camera going. Okay, so let's have a look at these. If I was graphing it, there's no vertical shift. that's, you're adding nothing. Your amplitude, you're only multiplying by 1 here. Your amplitude equals 1. So your high is going to be at 0 plus 1. Your low is going to be at 0 minus 1. You can just basically going to go up 1 to get your high, down 1 to get your low. Your start, you're not adding anything inside here. Your start is at 0. The period, aha. We're multiplying by 2. Our value of b equals 2. Your period is, 2 pi divided by b, so it's 2 pi divided by 2, which is simply pi. So when we go through our pattern, our step lengths are going to be 1/4 times the period. So that's like doing pi divided in 4. And what is our pattern for this? We have a sine wave, so the pattern is going to go middle, high, middle, low, middle. We're going to start at x is 0. We're going to take 1, 2, 3, 4 steps. Each of those steps is pi by 4. That's 1 pi by 4, 2 pi by 4. You could write that as just pi by 2. This is 3 pi by 4. And this one here is 4 pi by 4. And if you have 4 pi by 4, I hope you realize that's just pi. But look at it. We're going to finish away from the start to the finish. We're going to go through pi. You can only do that when your start's at 0. Yeah, so only time you can see that. So we're starting on the midline. Then our next step, we go to the high point. Then our next step, we go to the midpoint. And our next step, we go low to the low line. And then the last step, we end up on the midline again. So this is my graph here. Circle this first point. And if I went backwards, I only got room for 2 steps there. It would go, the next point would be middle, then it'd be back to low. That wouldn't be twiddling like that. It would be going up to high over there. Yeah. Okay. And this one would be heading off towards a high. Nothing ever comes out the top. Nothing ever goes out the bottom. Let's have a look at this one. I'm not going to actually graph this one. Let's talk about our start is. Our start is at x equals 0. Our period is the normal period divided by 1/3. Ugh. Now, if you left that like that, we never want you to do that. This is being called quad on this one. Remember, that's just another word for step. I prefer the word step. The step is a quadrant of the wave. You're getting that period and divided in 4. There's no way you could work with this. No. Simplify your work. Simplify all fractions. Dividing by 1/3 is the same as multiplying by the reciprocal of 1/3, which is 3. You turn that upside down and multiply it. 3 over 1. It would be 6 pi. That's the period. And your step is that period divided into 4, multiplied by 1/4. So that's 3 pi over 2. This would be 0. This would be 3 pi over 2. This would be add on another 3 pi over 2. It would be 6 pi over 2. This would be 9 pi over 2. This would be 12 pi over 2. Because we started at 0, this last step should be the same as the period, and it is. 12 pi over 2 is 6 pi. I'm not going to do that graph now. Let's graph something else. Okay, let's get you to graph this one. I'll leave you for a couple of minutes and see where you get to on that one. Please try and graph as much as you can. See what you can graph on your own without my help. You have a quiz on this on Monday. Okay, so we don't distribute that 3. That 3 is your value of B, and it must be factored out, or that start would be wrong. Our start is going to be at negative pi over 3. Our period is going to be at 2 pi divided by 3. And our step or quad is going to be at a quarter of that. Dividing it by 4 is the same as multiplying it by 1/4. So our step is going to be at 2 pi over, oh, that's a 3. 2 pi over 12, which reduces to pi over 6. But let's get graphic. The first thing I graph is the midline, and that's going to be at y is negative 2. My amplitude is not -1. The amplitude equals +1. So my high is going to be 1 above that, and my low is going to be 1 below it. Just go up 1 to -1, and go down 1 to -3. Okay, now what about this negative? What did the negative do? A cosine pattern normally goes high, middle, low, middle, high, but this negative is going to turn the highs into lows and the lows into highs. So if I was graphing this, my pattern this time, if I want a table, goes low, middle, high, middle, low. My first point, my start, is at negative pi by 3, but I'm going to be adding 6s to that. So this is going to be easier written as multiply that by 2 to get 6, so multiply that by 2. It's going to be easier, that's written as negative 2 pi by 6. Am I actually recording this? Yes, good. So, put your scale on the x-axis. Don't put it on the midline, put it on the x-axis. I'm going to start, that point there is at negative 2 pi by 6. This will be negative pi by 6. And I'm going to take from there, I'm going to take 1, 2, 3, 4 steps. So I'm starting at negative 2 pi by 6, and I'm simply adding pi by 6. You do not have to do this table, and certainly don't have to do this stuff I'm writing at the bottom. But if it helps you, then please do it. I'd rather get it right. This could have been written as pi by 3 if you wanted to, but I'm not going to get fussy about reducing those. So let's see, I've got to start on the low. So I'll do these points in blue. I'm starting on the low. I take a step to negative pi by 6, and I graph a point on the midline. I take a step to, these are x values, so x is 0. So it's not taking me to the origin, it's taking me to the high line. When x equals 0, y is on that high line. Then I take a step and I'm on the midline, then I take a step and I'm on the low. And that would be one wave. It would be going up after that last point, back up towards the middle. Circle your first point, and now we could go back if we wanted to, take 4 steps backwards. 1, try and make them the same size. And label, this would be negative 3 pi by 6, this would be negative 4 pi by 6, this would be negative 5 pi by 6, this is negative 6 pi by 6. Oh, negative 6 pi by 6. That's kind of negative pi. I might as well reduce that one. So from a low, it's going to go to a middle, to a high, to a middle, to a low. That's what your wave should look like. Now I'm going to quickly show you what I've got up in my room here. and I'm going to try and talk you through it. So I'm going to have to carry my camera. I hope this works for you. These are some graphs students did years ago in my classroom. My lead's not long enough. Can you see that a sine and a cosine wave, they look identical? It's just a cosine wave has been sort of shifted one step, pi by 2 to the left. Cosines, you can see where it says theta equals 0, and there's a sort of bolded, almost black line, vertical line on both graphs. That's supposed to be your y-axis. Can you see from those graphs that the general shape of both of those waves, it's a continuous smooth wave just going up and down and up and down and up and down. If I started at any high point on any wave, it would go high, middle, low, high, middle, low, high, middle, low, high, middle, low, forever and ever. And going backwards, it goes from a high to a middle to a low to a middle to a high to a middle to a low to the middle. Yeah, they always are smooth and continuous, a regular pattern. Why I wanted you to see that is so that you know when you've finished your graph, look at it and just think, is it basically doing this the whole way along my graph? If your graph ever looks like this, you know that's wrong. That would never, ever happen. You know you've gone wrong, okay? It only ever goes in a continuous way. Okay, right, I've got 2 periods I want you to work out for me. We're not going to do another graph now, we're not going to have time for that, but we have got time for this. On these ones, look at the question. I want you to, particularly do the first one. I want you to work out the period and the step size, and on this one I want you to go back and do the start. I'm going to give you a minute to come out with those values, and I'm going to go over it. It's not very long. If you do the second one, I'll talk you through the second one as well, or we'll do it together. So on this one, remember the period is 2 pi divided by b. That's our value of b. So it's going to be 2 pi divided by 4, which is pi over 2. To find your step, you can say the period divided by 4. Now that's horrible to do. Remember, instead of dividing by 4, you can simply multiply by a 4th. It's the same math. That's much easier to do. It's going to be pi over 8. Now your start, this is not C. Why is it not C? Because you have to factor out B. Your start is going to be at negative pi by 4. On this one, oh, look at this one. Your start is going to be at 1. Your period is going to be at 2 pi divided by your value of b. Here's your value of b. It looks so ugly there, but look what it means. It's wonderful. It means your period is just 2, and it means your step is simply 2 divided by 4, which equals a half. This one is going to be so easy to graph because your x-axis is just going to have numbers on it like 1 and 2. Much, much easier. That looked ugly, but it meant the question was much easier. We have enrichment now. If you want to stay on, if you've got any questions, you're welcome to. We have nothing special in enrichment today. You can stay with us for the announcements, or you can leave.